So, the Meselson Stahl experiment, that's what most of the questions are about. In the Meselson Stahl experiment, they use Escherichia coli that is grown in a food source with the isotopes 15, isotope 15 and isotope 14 of nitrogen. They thought that since DNA anyway is made up mostly of nitrogen because of their nitrogen bases, they will use these isotopes, incorporate the isotopes to check if the replication would really occur in a semi-conservative manner, meaning is isotope 15 present after several cell division or DNA replication, or will it be absent because the original DNA will not have it. In their experiment, they added E. coli in a culture with isotope 15 of nitrogen. This was allowed to reproduce to make sure or to give ample time for the DNA to acquire the isotope 15 that they used. Then they took samples, and then these samples are centrifuged to check for the presence of 15 isotope of nitrogen. This one is the generation 0 of your E. coli. They picked some samples and then they transferred bacteria, the E. coli, into the isotope 14 of nitrogen. Okay, then after they transferred it, they allowed 20 minutes, I believe, 20 minutes for this bacteria to reproduce, because that's the minimum time for bacteria to increase in number. Then they took this bacteria as their first generation. After that, this bacteria is then allowed to reproduce again for the second time and the third time. And that one is the second generation and the third generation respectively. In each of this first, second, and third generation, they still took the sample of the DNA and checked it. Then they centrifuged it. Okay. Once they took the DNA sample is added with cesium chloride, and then allowed to be what do you call this one, put in a centrifuge. The centrifuge is important in here because depending on how heavy the nitrogen that is present, it will have a specific place in a test tube. Okay, they used nitrogen 15, right? Since 15 is obviously heavier than 14, nitrogen 15 will be present at the bottom part, while the nitrogen 14 would be present in a upper portion of your sample. So this is a table that shows the summary of all the generations that they have. You have here a test tube, and in here you have the, I forgot, right, generation. The first column would be the 0 generation, the one with N15 only. The second column would be the first generation, the one that was allowed to reproduce in 20 minutes. And the succeeding others are, of course, 2, 3, and 4, wherein this E. coli are allowed to reproduce given an ample time in each interval so that they could take in the nitrogen 14 from the culture. In this test tube, we could say that the first half in here would be where we could find the nitrogen 14 because, as we said, it's lighter. And in this lower portion, we could find the nitrogen 15 because, of course, nitrogen 15 is heavier. So, going or focusing on N15 generation, the zero generation, all the cells have only a band that is in the N15 section. Okay, it means that all the DNA would have only contained the heavy isotope nitrogen, which is nitrogen 15. Next one, in the second generation, it also produced a single band, but it is not in N15 nor in N14. Rather, it is in the middle of the two. So what does it mean, miss? The meaning or the probable reason why the band after centrifugation is in the middle is because the DNA will have both nitrogen 14 and nitrogen 15. Since in here, technically, it's a hybrid of the N15 and N14, we could say that this will fit into the theory of the dispersive and the semi-conservative model, but not the conservative model. If it was in the conservative, or if it would be agreeing in the conservative model, there should be two different or two separate bands in this generation. Now, focusing on the second generation of bacterial growth. In this second generation, this is where they were able to distinguish whether is it dispersive or semi-conservative. As you can see in the image, there are two bands, right? One in N14 and one in N15. This proves to Meselson and Stahl that the DNA is actually made up of two separate strands, of course, the old and the new, and one of the two would be coming from the old generation, or it would be made up of the new ones, which was the N14. This proves that the DNA is replicated using the semi-conservative replication theory. This one is not considered as a dispersive replication because if we could remember, this dispersive theory would have old and new stuck together, right? So if it is like that, then it is impossible for us or for Meselson and Stahl to get a pure sample. Therefore, it will have a very light molecule or a very light band in here, and not these numbers 50-50. It would be way lower because it is difficult to determine since it is in a how do you call it? It's in a fragmental matter. It's how it is. In the third and fourth generation, we would be expecting that this and this would be having a hybrid. Therefore, the resulting or the new DNA would be not somewhat present in here in this band because they because they would represent the a smaller fraction of the total DNA. Therefore, in here, the older one will be 25, then the new one will be more of the N14, and in the fourth generation, you could see that the N15, the old strands, would be of 12% only, but the newer ones would be more of the N14. And because of this pattern that they saw, Meselson and Stahl were able to prove that the theory that is most likely happening in DNA replication will be the semi-conservative method. So in conclusion, in this experiment, Meselson and Stahl were able to prove that the DNA does replicate in a semi-conservative manner. And that is what's important in this experiment. Ciao!